Hello once again, everybody. So today's lesson is on multiplication with polynomials. And really what this lesson boils down to is a lesson in distribution with polynomials. Okay? So that's what we want to be thinking about when we're doing these problems. So the most basic one is really multiplying one polynomial by a binomial, okay? So if I have 6x multiplied by 3x squared minus 4x plus 2, I want to think in terms of this operation, which is implied multiplication, okay? So when I have a variable right up next to the parenthesis, I'm saying multiply. And the important thing here is I need to think in terms of multiplying what's outside the parenthesis by what is inside the parenthesis, okay? So really what I have here is 6x times 3x. This operation stays out in front, so minus 6x again, because I'm distributing it, times 4x. Here's my operation, plus, and this should have been 3x squared. Sorry about that. And then plus 6x times 2, okay? Now, this distribution, this multiplication, boils down to just the simplest of things. So 6 times 3 is 18. X times x squared. Well, remember, my bases are the same, so I add the exponents. Operation. 6 times 4 is 24. My bases are the same, so I add the exponents. And then 6 times 2 is 12 times x. And now I go back and I just simplify my exponents. So I have 18x cubed minus 24x squared plus 12x. And as a quick check, I want to make sure that this term right here, okay, could I see where this term goes into this term, all right? Will 6 go into 18? Yes, 3 times. Will x go into x cubed? Sure it will. Remember, that's just that division we used to do, where I have x cubed over x, and that becomes x cubed minus 1, or x squared. There's an x squared. 6 going to 24, 4 times, good. X going to x squared, x times, good. 6 goes into 12, 2 times, and then x goes into x, 1, okay? So this checks out by just thinking in terms of division, okay? So what happens now if I have more than a monomial, okay? What if I had x minus 3 times x squared plus x, okay? So on a problem like this, I'm still thinking distribution, right? So this term has to be multiplied by everything over in this term, right? Just like now this term has to be multiplied by everything in this term, okay? Now, when I have a binomial times a binomial, you've probably seen this before, is FOIL, okay? So x times x squared is the F. X times x is the O, because that's the outer. This is the first. 3 times x. Well, that's my I, because that's the inner two terms. And then L is last, because it's the last two terms multiplied together, okay? So when I write this out, I'm going to say, all right, the first is x times x squared, right? So there's my first. I'm distributing, right? I'm moving it one-on-one on everything. So here's my operation, plus x times x. There's my O for FOIL, okay? So I've taken this term, I've multiplied it by everything in this binomial. So then I move to the next term. So I have minus a 3, and it gets distributed to this innermost term. Okay, so there's my I of FOIL. And then I distribute again, minus 3, to this last term. And there I have my FOIL, okay? First, outer, inner, last, okay? So we can write that as F first, O outer, inner, and L last. There's your FOIL. Now I just go through and do the multiplication. So here I have x, my exponents are 1 plus 2, plus x, my exponents are 1 plus 1, minus 3x squared, right? Minus 3x, okay? So that's what that equals. So let's do some simplification. X cubed plus x squared minus 3x squared minus 3x. And notice I have like terms here. So I can simplify those by saying I have 1, look at its coefficient, minus 3, which is minus 2x squared minus 3x, okay? So that's how you go about multiplying a binomial by a binomial. You just have to make sure everything in the first term is multiplied by everything in the second. Everything in the first term is multiplied by everything in the second, okay? So let's do another example here. Let's say I had x squared plus x minus 3 times 2x squared plus 6x minus 4, okay? So my process stays the same. I have to make sure x squared is multiplied 3 times, because I have 3 members here, that x is multiplied 3 times, and that minus 3 is multiplied by 3 terms here. So here I have x squared times 2x squared plus x squared times the 6x plus x squared times the minus 4, okay? Now, obviously, I'm going to run out of room here, so I'm just going to have 3 rows to represent the 3 different terms here multiplied, okay? So now I would have plus x times 2x squared plus x times 6x plus x times the minus 4. Okay, minus 3 times 2x squared minus 3 times 6x minus 3 times minus 4. Now, what's really neat about this, when you do it this way, notice each one of these columns here matches this first term, right? x squared plus x minus 3, all 3 times. So that's a quick check that I have, in fact, done everything from this first polynomial. Now look, these 3 columns, each column should have each member here. So as long as this first column has all 2x squareds, as long as this column has all 6x's, and as long as this column has all minus 4's, I have written down every element to now multiply, okay? So this format allows me to make sure I've done everything, because that's where mistakes are going to occur, where we forget accidentally one of these. So now here's where maybe the more tedious part comes. So I look at this. I have 2x to the 2 plus 2, right? My exponents, plus 6x to the 2 plus 1, 2 plus 1, minus 4x squared, okay? Here I have plus 2x to the 1 plus 2, plus 6x to the 1 plus 1, okay, minus 4x, minus 3x squared, minus 18x. Now notice minus times a minus gives me a plus 12, okay? So let's simplify this. So 2x to the 4th plus 6x cubed minus 4x squared plus 2x cubed plus 6x squared minus 4x minus 3x squared minus 18x plus 12. Now, the simplest thing to do here is to take your time and group your like terms together, because with all these terms, it's easy to miss something. So let's do that. So I have 2x to the 4th. That's my highest term. I look to see if there are any more 4th powers, and there's not. So I just want to maybe draw a line through it so that I can see I have written it down here. So the next highest power is going to be a cube. So I want to go through here and find all my cubes and write them together, okay? So I only have 2 cubes, right? So I'll mark them out, and then I just double check to see if, and I did, I got them all. Now the next lower power is 2. So let's write those together. Plus 6x squared minus 3x squared. Do I have any more? Well, there's my minus 4. There's my plus 6. There's my minus 3x squared, okay? Everything up here is marked off. I can work down here at the end, and now I can just group my x to the 1st power, okay? I did both of those, plus 12, and I've now done that. One little tip here. I see this a lot where students will go through and they'll make a very heavy mark when they're crossing these terms out. When you do that, you can't double check your work, okay? Because you can't read easily what was written here. So just lightly mark out with one line or a different color like I've done, so that you can see everything here is now written down here. Because now all I have to do is combine like terms. I have 1x to the 4th term. I have 6x cubes and 2x cubes. So that leaves me with 8x cubed, right? And if you want to, you can even go through and say, okay, I did these now, right? So my x cubes are done. I need 3 of these x squareds. Now, there's multiple ways of doing this. You know, I can go ahead and say minus 4 and 6 is 2, and then 2 minus 3 is minus 1. Or since I've got my negatives here, I see that -4 and -3 is -7, and then +6 gives me my -1. So just take a look at your ordering and see if there's an easier way for you to add a string of numbers together. So for me, I get all my negatives and all my positives together, and then I just have two terms to add together. So -4 and -18, well, that's going to be -22x. And then I'm going to have my +12, and I have my solution, okay? So again, it's nothing but distribution. But as you can see up here, by using this format, I have my first polynomial, and then I have columns of my second polynomial, okay? So just writing it all the way out, I mean, look at that. That's pretty tough to look at and make sure you got everything done the right way the first time through, okay? So that shows me how to go about multiplying all sorts of combinations up to trinomials. And in this particular lesson, that's all we're going to really cover. But there's also a different way of looking at doing this multiplying that I want to show you, okay? And it follows along the lines of how we do regular column multiplication. So if I had 312 times 65, okay, and I look at that, I take my first digit here, my ones digit, and I multiply it by everything in the top. So 2 times 5 is 10. I carry my 1. 1 and 5 is 5, plus 1 is 6. And then 3 times 5 is 15, okay? And again, everything I'm doing, I'm keeping lined up in columns. When I move to the tens column, I'm going to start with my answer in the tens, right? So 6 times 2 is 12. 1 on to 6 times 1 is going to give me a 7. And then 6 times 3 is going to give me an 18. And then I just go columnar addition, right? So I get 8, 2, 1 onto that is 10, okay, for an answer there. All right? Same thing happens when I'm doing polynomials. If I were to have x squared plus 2x plus 3 times x minus 4, okay? I can set this up just like this, right? I can say I have, let's try to keep it all lined up, okay? So I'm going to move my x minus 4 down to here, okay? So I'm going to move it down here, and then just for the sake of being able to see it easier, I'm going to erase that so I don't have any confusion, okay? So I want to take my 4, just like my 5, and multiply it by all of these digits. So this is a minus 4 here. So minus 4 times 3 is minus 12, right? Minus 4 times 2x is a minus 8x. And minus 4 times x squared is a minus 4x squared, okay? So it actually produces another polynomial, doesn't it? So now I move to, just like I moved to the tens, I'm going to move to the higher power, and I'm going to bring its answer down under the column that has the same power. So x times 3 is 3x. X times 2x is 2x squared. And since this guy was positive, I can just put in a positive or a plus, right? And then same thing, x times 2x squared is a plus. And then x times x cubed is going to give me an x cubed. Now, just like here, when I added in columns, I'm going to do the same thing. It makes sense that I only have one term with no x's to add in this column, right? Because there's no way I was going to get a term without an x, because I'm adding an x essentially to everything there. So I have minus 12 minus 8 and 3. Well, that's going to be a minus 5x. Minus 4 and 2 is going to be a minus 2x squared. And then here I have nothing to add. I'm just going to get an x cubed, okay? So if I went through and I did this, by the other method with distribution, I would get exactly the same answer, okay? So we can take these terms and line them up and still do columnar multiplication, if you will, okay? So I have one other example that I want to go over with you, because what happens if I have a problem that looks like this, where I have 3 binomials in a row, okay? So just like we've always talked about, we want to take a problem and make it into smaller parts, okay? So multiplication, order doesn't matter, right? It's commutative. So I can multiply these two together first, or I could multiply these two together first, or I could multiply these two together first. It doesn't matter as long as once I'm done, I multiply by that binomial I left out. The easiest and safest thing to do, I think, is just take the first two in turn here, okay? So if I look at the first two, I just have a FOIL, don't I? Just binomial times binomial. So let's do that. So here I have x times x, or x squared. I have x times a minus 2, or minus 2x. X has been multiplied by everything here, so I'm good. I want to multiply the 1 times everything now. So 1 times x is going to give me an x. 1 times minus 2 is going to give me a minus 2. These 4 terms are the result of this multiplication. So I want to group them, because the result of this has to be multiplied by this last binomial, right? So it's really important that I group them this way so that I don't make a mistake in distributing these terms later on, all right? So let's go ahead and combine like terms here. And when I do that, this term becomes x squared minus x minus 2, doesn't it? And then I still have this last term to multiply, okay? My distribution does not change. I'm going to take x squared times everything over here, minus x times everything, minus 2 times everything, okay? So let's do that. So I'm going to have x squared times x. I'm going to have x squared times 3, aren't I? I'll go to my next term. I have minus x times x. I have minus x times 3. I'll go to my next term. I have minus 2 times x, minus 2 times 3. Just like before, here's my original polynomial, and here are columns of my second polynomial, okay? So now I just x squared times x plus 3x squared minus x to the 1 plus 1 here minus 3x minus 2x minus 6. Now that gives me x cubed plus 3x squared minus x squared. Look how these are. When I've got a nice descending order of power, I'm always going to end up with something that really adds together nicely, okay? And now I just have to combine these two. X cubed, that's going to be plus 2x squared minus 5x plus 6, right? So again, I could have changed the order up here, but for me, I find it easier to work left to right, keep bringing this binomial down and take care of this first one. And notice how I used that technique earlier of having a column of the first polynomial and then columns of the second polynomial to get my answer there, okay? So multiplication with polynomials, in summary, is really just what? It's just distribution, making sure everything in the first polynomial is multiplied by everything in the second polynomial. That's all we're doing when we do something like this, okay? Now, we introduced the term FOIL, and we'll be working with that much, much more. Keep in mind, FOILing only occurs when I have two binomials, okay? We're not FOILing this, we're distributing the 6x. We're FOILing the two binomials, and we are distributing the trinomial against the other polynomial, okay? So that concludes our lesson for today, and I will see you next time.